In order later to provide a quality printout, the intro discussion is fairly long, about 8 minutes, but please be patient. It should help in understanding the theory. Before going into the facts and basic math, first let me explain what my basic theory is. I am a retired electronic engineer who designed transmitter and receiver electronics for many companies, including TWA, Bendix, Northrop, Sprint, and several others. These are but examples in order to convince others to consider this theory with an open mind. It's called the Winter Time Chill Dilation Theory. What this theory states is that the current theory of universe expansion with acceleration is only one way to interpret the data from the spectrometer readings of Hubble and other similar observations since. Redshift, usually caused by the Doppler shift effect, indicates the universe is now in an accelerated expansion. It shows the light of galaxies far away to be shifted more to the red color in the spectrometer's prism spectrum display than galaxies that are close to us. My theory is that the universe did not even require a Big Bang, only an extremely hot nuclear fusion plasma source that started cooling and spreading out matter a long time ago. It also could have been a Big Bang, as currently suggested, but with much less expansion, and even so my theory would still work. If time, as I suggest, has slowed down, then the universe redshift data shown would also be the same as it is now and not require a Big Bang, but having a smaller expansion and likely now near absolute zero temperature and be nearly static with minimal time dilation currently, with the microwave background noise temperature still slowly cooling off but never quite reaching absolute zero. It just takes much more time to move between objects in our current universe than it did a long time ago. The redshift seen is time dilation, not expansion, with acceleration. But instead, my theory suggests, is time slowing, causing the visible galaxy separation increase with no Doppler effect required. This universe time slowing also gives exactly the same redshift numbers as does Doppler shift today. More data than just redshift is required to truly prove either way which theory, current or mine, is more likely correct. Before this time, the fourth dimension, I believe, was moving much faster. Time is the fourth dimension. But as the universe cooled, time started slowing down. It has now cooled down a lot. If we check it right now at any long distance from any star that will heat up the object being measured surface, it is only 2.7 degrees Kelvin, near the current temperature of Pluto's surface. Yes, this is the only 2.7 degrees above absolute zero. This is also the temperature right now of the microwave background radiation noise. It was at a much higher temperature in the beginning, though. Measured frequency waves then were also much higher in the plasma's emitted radiation, which we see today as the microwave background noise. An ultraviolet frequency that measured 800 megacycles, that's 8 to the 14th power, is now picked up at a much lower microwave radiation frequency of 375 gigacycles. That's 3.75 to the 11th power. There's a power of 3, it's been reduced. This is also demonstrated in current redshift data. It has been proven higher frequency has higher energy level than lower frequency. Time increasing, I believe, costs this energy. A good example is that Einstein proved, and has been verified many times, time is relative, depending on what time dimension you are in when compared to another. What if your current position right now in the Earth's was instead in the Andromeda galaxy, as just an example, not the Milky Way? It may only take 1 second to walk 10 feet, but on the Milky Way's Earth it takes you 2 seconds to walk 10 feet. Either way, when you're walking, it seems to you the same amount of time, only 1 second. In other words, space and location depend on the scale of time, which changes relatively all over in our universe. 1 second somewhere else is a different length of time, yet only seen as different to an observer in a different time dimension. Since Andromeda is not traveling through space at the same speed as our Milky Way galaxy, Einstein and many others following proved it is in a different time dimension. Thus, at least one form of time dilation has been proven. First, let me show a video of what frequency and wavelength mean, then show very basic math to demonstrate my theory along with examples. At the end, I will show the links to my website, newcow.com, where a hard PDF copy of my theory can be printed out anytime, 24/7, totally free, with no garbage included or attached. Pause the video when the link is being shown so you can write it down and place it into your browser. I did this so it's in the video and not easily deleted. I have no current desire to write another dull research paper for any scientific journal and have them dictate format and profit from selling copies of this theory in a research paper form. It is not only for others in an academic field, but free for anyone with a minimal of mathematics to understand and consider. This theory is provided openly in the hope someone will do additional research to further advance its validity. As theory author, a reference to me used in any additional research will be appreciated. All reasonable thoughts or comments on this video I will consider and are welcome. So, let's begin.
Transverse waves are waves in which the vibrations are at a right angle to the direction of wave motion. Light, the vibrations of a pluck string, and water waves are all good examples. Let's look at a water wave. The wave travels from left to right, and the vibrations are up and down. The vibrations are said to be moving in a transverse direction to the direction of motion. If we look edge on at the wave, we can see that the up and down vibrations are symmetrical about a center line. The maximum distance the vibration moves away from the wave center line is called the amplitude of the wave. The amplitude essentially tells us how noticeable the wave is. For water waves, you would hardly notice a wave with a 1 mm amplitude hitting you. However, a 10 meter wave will grab your attention. The situation is similar with light. The amplitude of the wave tells us how bright the source is. In fact, the amplitude is related to the power that the wave carries. It is reasonably obvious that the wave is regular in shape. This means you can identify a section of it that can be repeated end to end to make up the whole wave. If you measure the length of this small repeating section of the wave, then you have measured the wavelength of the wave. Remember that the wavelength is the length of a section length that when placed end to end gives the whole wave. Now let's unfreeze the wave and let it move again. The wave is moving from left to right at a constant speed. This is called, rather obviously, the speed of the wave. The speed depends on the type of wave and what it is travelling through. For water waves, for example, waves travel faster in deep water than they do in shallow water. This effect leads to tsunami waves. Imagine that I stand in a fixed position and count how many peaks pass me in a given time. I might, for example, count 20 peaks in 10 seconds. I can then ask, if 20 pass me in 10 seconds, how many would pass me in 1 second? The answer is 20 divided by 10, so 2. I can say the frequency of peaks passing me is 2 per second. This is the frequency of the wave. It doesn't matter whether you count peaks, troughs, or somewhere in between, as long as you count the same part of the wave every time. Now imagine I have two waves of different wavelengths, but moving at the same speed. If one wave has twice the wavelength of the other, then the frequency of peaks on that wave passing a point will be half that of the other. So frequency and wavelength are related properties. In fact, the frequency can tell us how long it takes for one wavelength to pass. A frequency of 2 per second means that each wave takes 1/2 of a second to pass a point. We know how long the wave is from the wavelength, so we know the distance travelled in this time. From this we can work out the speed of the wave as distance travelled divided by the time taken. This turns out to be equal to the frequency of the wave multiplied by the wavelength of the wave.
In order to clarify things a little bit, frequency, such as 1 cycle per second, is also called 1 hertz per second. It used to be called cycles, now they changed it to the name hertz. So when you hear things like megahertz, think megacycles, million cycles. When you hear things like gigahertz, that's 10 to the 9th cycles. And, just mega is 10 to the 12th cycles, or hertz. Cycles are now hertz. Also, the scene you see behind you is the actual microwave background noise, and it sure looks like the same molten plasma was on the surface of the sun, so that's why I believe it's very likely to be nuclear plasma. Well, you now have a knowledge of C cycles, hertz, and wavelength. Of course, cycles per second is the same as hertz per second, and the wavelength is actually the length of one cycle in meters. Well, the question was, how much was time faster in the beginning? Actually, to consider that, we have to consider that time slowing down was most likely a curve, an S-curve, something like very fast in the beginning, then linearly slowing down, and now still slowing down, but at a very little rate. Comparing beginning to now, we can do a fairly simple group of calculation. This graph shows wavelength in nanometers for visible light. We're interested in this 375 nanometers. This is the actual wavelength of the beginning of ultraviolet. It's in this little band. The WMAP satellite says that this high frequency now has been due to what we call time. They call it a universe expansion. Clear down here in the radio waves, 10 to the 9th. Let me move on to why we care about that frequency in particular. Here's a straightforward plot that shows the nuclear radiation output wavelengths that our sun puts out during every day of its nuclear fusion. And this side really says irradiance per watt per square meter compared to the nanometer wavelength. Right here at 375 nanometers is where the highest output of our sun is, assuming that the primordial mass fusion that started the actual universe was the same with hydrogen, then it also would likely have this 375 nanometers as its highest output frequency. This is what we want to use in our calculation to show now that it's actually dropped down to 160.3 gigahertz from 375 nanometers, and use that in our calculation, which we're going to proceed to right now. I'm going to give you time to read this a little bit, and then I'll try to explain, or at least attempt to explain what my theory really is. Okay, I hope you read it, or you could put it on pause and do that. What I'm really saying is that time was faster at the beginning of the universe. And because the universe has slowly cooled, time is also slowed. Therefore, it has increased the distance between the objects, not because of some hidden force, but simply because of time dilation. And an example of that would tell you that it just had to be a hot plasma. There actually didn't need to be a bang at all. The separation between particles would be time separation. All this also works for a Big Bang as well, the same theory. To demonstrate this, we use the frequency formula for light. 300 divided by the wavelength in meters equals the frequency in megahertz. Okay, so if we take the 375 nanometers divided into the speed of light, we get up 800 million megahertz is the actual frequency of that ultraviolet light, which is our sun's greatest radiation level. Of course, we don't know back at the beginning if that was the highest radiation level, but that's a good example of demonstrating this time dilation theory. Today, the highest level of background noise in microwave that we can measure is at 160.3 gigahertz. So if we can run that out, that comes out to 1.871, etc. millimeters for this frequency. Okay, if we take the 800, which is what it was, million megahertz is what it was at the beginning, and we now say it's dropped down. What we're measuring, the UV now has become 160.3 gigahertz. It's 4,900 0.64 etc. times faster in the beginning than it is today. In other words, light was actually moving that much faster. But it wasn't light moving, I'm sorry, it was time moving that much faster. See, I keep doing the same thing. So here we show it again. This actually confirms it and back out the calculation. So 1 second, light today travels 300 million meters in a second. Back then, light traveled 1.497 etc. million megameters in the same 1 second. Because of the temperature decrease and the expansion of light, time. I'll let you read this part as well for a bit. So again, you can put it on pause, but let me at least describe this somewhat. 800 million megahertz has now become 160.3 gigahertz. Not because of the universe has been expanding, but because time has been expanding. And of course, time dilation, Einstein's formula has been proven many times with GPS, satellites, outer space by NASA and most scientists. So there's no disagreement that time dilation really does exist. But to say the expansion is caused by some dark energy rather than time dilation, and we have no evidence for, seems quite far-fetched compared to this theory. And also, light velocity remains constant, which is what Einstein has been saying for years. Now the expansion has come very close to zero. But, that hasn't been added in as a variation in the time expansion. But don't really need that to demonstrate this theory. Okay, a proton now near absolute zero, 1 or 2 degrees, they've actually stopped the proton, scientists have, from moving. So now the proton thinks it's frozen in time. No, it doesn't. I'm sorry. We think it's frozen in time. It thinks it's still moving at the same time. It's in a different time dimension than we are. So therefore, seating in a rocket with the windows closed, you do not know what time velocity you are traveling either, so neither does the proton. Electromotive force, the waves, and light speed are constant. Einstein's biggest blunder, they keep talking about his biggest blunder, was listening to Hubble. A cosmological constant in his equation is not required. You can just add an added time variable. Let me continue here. So if this is true, then we should be able to measure this time variation, and it should violate gravity if there is a time violation. Variation, sorry. Okay, the distance between the Earth and the Moon is a good example of time variation. And this is, guess what? It actually is. The distance between the Earth and the Moon changes and increases 3.8 centimeters a year. This has been confirmed many, many times by NASA. They have mirrors on the Moon. The astronauts put it on there in the early 70s and using a laser to measure it. The Moon is actually in an elliptical airport. Elliptical. It doesn't have a circular form as it goes around the Earth, which means it moves in and out somewhat. So they've taken the average and calculated, and it's still 3.8 centimeters. In a minute, I'll give you a video of that showing what it looks like. Let me let you go ahead and read this. So what I'm really saying here is that Einstein said that if you have more mass, the warp of time, space, would go inward. So the Earth and the Moon ought to be getting closer, not farther away. They're gaining mass. But not only that, they're also gaining in diameter. And yet they aren't. That's proven. It's actually, they're spreading apart. Well, what causes that? Same thing, small time dilation. Okay, and then this actually is much more plausible than some kind of weird wobble shifts over so many years and invisible dark energy fields. Let me show you how they actually got the average. Yes, this is how they calculate the average distance between the Moon and the Earth. It starts close up from this view and starts moving out farther and farther. This is a period of about 6 months. With the mirrors on the Moon and the laser, they take an average out of all of the various nights, 365, and come up with the 3.8 centimeter that the actual distances change between the Earth and the Moon. New information, I did some searching, really hard to do, but I actually located some other scientists that have a similar theory to mine. And in the next presentation here, I'll be showing that. This is the first page of a 4-page, very brief article that I was able to find where scientists in Europe actually had similar theory and thoughts as to mine. This is way back in December 28th of 2007. Still no reaction. Let me go to page 2. This basically just says what the most common theory at the moment is. Here you see they actually talk about time being faster in the beginning and now slowing down. Of course, they're into the multi-dimensional brain and string theory and multiple dimensions of time, rather than my theory, which is really quite straightforward. It just says it's temperature that's dropped. And at any rate, page 4. Of course, if it ever got cold enough to freeze a proton like we have done near absolute zero, light would stop. So unless we we would see it as stopped and go away as well, but it'd have to reach absolute zero, which is, that actually calculates out to infinity, so that's not going to happen. The two articles are from the Telegraph UK and the New Scientist. Also on the previous page, it shows a link to their actual research document. Well, that's about it for this one. I will have another video very shortly because I've discovered a time machine, how to actually make and build a time machine, and for almost no money, that will send signals into the future, not just the past like we have been doing for many years. Go through that. Be sure and visit that other video too. Thanks for watching.